Hello, and a warm welcome to all the audience of this course. This course is entitled Analysis of Trust Structures, a Numerical Approach. I am your instructor, Dr. Gaurav Tyagi. I am a PhD from BITS Pilani campus, and I did my postdoc from Northwestern University, Illinois, USA, and also I did my second postdoc from University of Pittsburgh, Pennsylvania, USA. I am an associate professor in the Department of Civil Engineering at SR University, which is located in Warangal, Telangana, India. So in this course, we'll be discussing all about trust structures in great details, and I heartily welcome all of you in this course. So let's get started. So first of all, we have to understand that what is a trust structure. So here we can see on the screen what is the definition of a truss. So a truss is a circular, I mean, I'm sorry, a truss is a structure. So it's a structure, right? It's a civil engineering structure. What is a structure? Structure is assembly of members formed by combining linear structural members. Okay. So a truss is made by combining linear structural members. What are linear structural members? We are primarily talking about bars, which are slender in nature. They are slender bars. Okay. What are slender bars? If L is the length of the bar and D is the diameter of the bar, then L by D is very greater than 1. That means L is very large compared to D diameter. So that is a definition of a slender member. So as you can see in the pictures here, we are having different kinds of bars. This is one bar, second bar, third bar. Here also airplane wings, you can see different kinds of bars are there. So trusses are composed in their entirety with bar elements. Okay. The key structural characteristic of a truss is that internal load it carries are exclusively or primarily of an axial nature. Okay. So the loads which the truss carries, they are axial in nature. Axial in the nature means, let's say we are having a bar, it is subjected to either tension or compression. Okay. So let's say you're having a bar, it is having either tensile force or in the second case, it can have compressive force. But the force is always passing through the axis, is aligned along the axis of the member. Therefore, they are known as axial forces. Okay. These structures are internally stable in the sense that the only change in the shape under the load is due to deformation of the truss elements. So because the members of the truss, which are the bars, are subjected to axial forces only, therefore they undergo a change in length only in the axial direction. So if this is the bar, after compression, it can become like this. After tension, but the change is always in the axial direction only. You can see the change is always in the axial direction only because the load is assumed to be applied only at the axial direction only. Okay. Trusses have played a major role in the structural design due to their unique structural efficiency characteristics. So actually we will find that the truss members or the truss structures are very important as far as the civil engineering structures are concerned. So now let us understand in more detail what is a truss. Okay. A truss is an assembly of straight members. I already explained to you. Connected at joints. Okay. So no member is continuous through a joint. What does it mean? It means that if I'm having two truss members, they are joined only at their endpoints like this, and no member is continuous through a joint. That means no member is extending beyond the joint. This case is not possible that this is a single member, this is one member, and I join another member at some mid length or at some other length of the I mean bar. Okay. So we are always connecting the bars end to end. That is the first thing. Second thing, every member of a truss is a two force member. Two force member I already explained to you. Either it is the case of tension as it is shown here, or it is a case of compression. Okay. Either tension or compression. So therefore there are two force members. And trusses are assumed to be of negligible weight compared to the load they carry. Okay. So we are assuming that our truss members, which are the bars, are not carrying any weight of their own. Because for example, they are being subjected to compression. So they are carrying only that load, compressive load. But if you assume that the bar itself is having some weight, what we are saying is that there is some sort of UDL over the bar, which is nothing but the self weight of the bar. And because of this UDL, will have some sort of bending moment also. But that goes against the definition of truss members that they are having only axial force. They are not having any kind of transverse loading through them. And therefore, we assume that the truss is not having any self load. Okay, there is no self weight. And also, there is no application of force also in the transverse direction. Forces are applied only at the joints. Okay. Most structures are made up of several trusses joined together to form a space framework. Each truss carries those loads which act in its plane or may be treated as a two-dimensional structure. Okay. So most structures are made with several trusses. Like here you can see this is one truss, this is second truss. Okay, so generally the all the structures, like in the previous slide also, you can see how many one truss, two, three, four, five, six, seven, and here count lot many are there. Here also lot many are there. So generally they are made with a large number of truss members, okay, and truss structures. Now bolted or welded. So the next characteristic is that the bolted or welded connections are assumed to be pinned together. Okay. So bolting is fine. If we do the bolting also, I mean very tightly, it deviates from the pin connected nature. But if it is welded, then surely it is having a fixed joint sort of behavior. But in real life, although the truss members may be bolted or welded, but for the present analysis, are pinned together. Okay, only two force members are considered. Okay, forces tend to pull the member apart. It is in tension. Forces tend to compress the member. It is in the compression. Okay, so that we already saw. So now here is an example of a truss bridge, and you can see that this left hand side part is also having several trusses connected together, and at the right side also this is having multiple trusses connected together, and there is a floor. Members of a truss are slender and are not capable of supporting large lateral loads. Okay, so this part I explained previously also, that the truss members cannot take the lateral loading, they can only take axial loading. So weights are assumed to be distributed to the joints. So even if there are some weights in the members, we'll assume them to be concentrated at the joints. So this is a sort of idealization, because the weight is actually distributed throughout the member. but we will assume for our calculation purposes that the weight, if any, is concentrated at the end points of the bar. Okay. Excuse me. The external loads transferred to joints via stringers or floor beams. Okay. So loads are always going to come to the joints only. You may require different kinds of members like stringers or floor beams to bring the load to the joints. Okay. But ultimately joints are the one who are going to experience the loading in the truss structure. So here we can see different kinds of truss structures. The first is known as the Pratt truss. The second is the Hove type typical roof trusses. Third is the Fink truss. Next is the Pratt truss. And then the Hove truss is there. The Warren truss is there. The Baltimore kind of truss is there, and K truss. So these are the different types of truss structures which are named according to their particular arrangement of the bars, and these names are fixed. But from our present course perspective, we don't need to memorize the names of the trusses. Okay, we should just understand that there are different kinds of trusses, and probably you can remember a couple of important ones like Pratt truss or Hove type roof truss, like that. Okay, so the now we are going to consider that what are the different ways to classify the trusses. Okay, the trusses are classified based on two parameters. What are those two parameters? The first parameter is the geometry, and the second criteria is determinacy and stability. Okay, so geometry is the first one, determinacy and stability is the second one. Okay, so now we are going to see one by one which are the different types of trusses. So first one, we can see here that coplanar trusses are those where the members and the loads lie on the same plane. Okay. For example, I am having a truss. In this case, we can see that members and the loads lie on the same plane. So this is the plane of my screen is a 2D plane, right? It's a 2D plane. It's not having the height component. It is having only the length and the width. So the members and the loads lie on the same plane. So right now this truss is lie in the 2D plane. And if we see the loading is also going to act in the 2D plane. Then it is known as coplanar truss. The second type of truss is 3D truss, where the members are connected at ends forming a 3D structure. Okay, so here is an example of a 3D truss where this right side panel is one 2D truss and left side panel is again 2D truss and the back side is also 2D truss. Okay, but now they have been joined together to form a 3D truss. Sorry. So now we are going to see the simple trusses. Okay, the heading is simple truss. So now it is the simplest framework that is rigid or stable. Okay, so this is my going to be the simple truss, simplest one. It is the rigid and stable. So if I'm having a 3-member truss with a pin support and a roller support and I apply some load P, it is going to be a stable one. It is not going to collapse. Okay, and therefore, because of its simplistic arrangement, it is called a simple truss. Now, how do I make simple trusses? For making the simple trusses, I have to first of all make a triangle and then go on adding different members. Right? So in the simple trusses, we have triangles as the primary unit. So, since triangles are a stable form, the simple truss usually consists of triangles. Okay. So after simple truss, we have second one, which is complex truss. Oh, sorry, compound truss. In the compound truss, we are having a combination of two or more simple trusses. Like here you can see this is one simple truss, and this is another simple truss, and this is a member. After joining these simple trusses, we have got a truss which is called complex truss. Oh, sorry, compound truss. Okay, similarly here we can see this is one simple truss, this is second simple truss, and we have joined them together via these bars, and we have got what? Compound truss. Now, here is another example of compound truss where this is one simple truss, second simple truss, third simple truss, and which is basically these three simple trusses are replacement of three innocent bar members which were most probably there in that simple truss. Okay, so remove the members of a simple truss and place a simple truss. Instead of that, remove a bar of compound truss and place a simple truss. It becomes compound truss. And the third type of truss is complex trusses, which are neither simple nor compound. So if you carefully see this figure, you will you will find that it is neither simple truss nor compound. Now, how do we analyze the trusses? For the analysis of truss, for analysis of truss, we are going to see few things. The first thing which we have to understand is that what are the unknowns which I am trying to find. Okay. So for example, if I'm having a simple truss here, which is having members like this, in the truss analysis, what are the unknowns? I don't know the force in the member B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, B11. So first of all, I don't know the member forces. Apart from member forces, I also do not know the support reaction. Let's say this point is A, so I don't know AY and AX. And here if I go, I don't know BY. Okay, so just count how many unknowns are there. 1, 2, 3, 3 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and how many joints are there? 1, 2, 3, 4, 5, 6, 7. Number of joints is equal to 7. Okay, so at each joint, at each joint, you can solve two equations. One is summation fx equal to 0 and second summation fy equal to 0. Okay, so if the number of joints is j, so we have 2j equations. We have 2j equations. So number of unknowns, if they are equal to the number of equations we have, then we have a statically determinate structure. That this we already know from mechanics of solids, right? So here we see that number of unknowns are 14 and number of joints is 7. So 7 into 2 is 14, which is equal to this 14, which means that this beam is a statically determinate beam. But if I add one more member here like this and provide a joint here like this, then immediately I will find that the number of unknowns have become more than the number of equations that I have. Okay. Of course, in this case, the joint is also going to increase. So just to tell you the principle. So now for the stability, if B plus R is less than 2J, then the truss is going to be unstable. As you can see, it is the joints which are responsible for the stability of the truss. So if the number of joints are becoming lesser than the members, that means we are introducing more members and less number of joints. So the truss is not going to be stable. There will be insufficient number of bars or reactions to constrain all the joints. Okay. So if we are having more joints and less number of members, so here is an example. If this is the case, this is a truss and number of joints are 4, j equal to 4 and b plus r equal to 1, 2, 3, 4, 5, 6, 7. So number of unknowns are 7 and number of joints is 4. So our condition is if b plus r is less than equal to or greater than 2j, then here we will find that 7 is less than 2 into 4, which is less than 8. This is a kind of unstable truss. Okay. A truss can be unstable even if it is statically determinate or statically indeterminate. We are going to see a few examples on this in the coming slides. In this case, the stability will have to be determined either by inspection or by a force analysis. Okay. So here, external stability. If the truss has all its reaction concurrent, concurrent means they are meeting at one point. That is the meaning of concurrent. So here you see two reaction forces, they are meeting at this joint. So these are concurrent. Such a beam is going to be unstable. Okay. And second case is, as we can see, the truss is simply going to come down because it's a roller support here and a pin support here. The pin support will allow rotation and wheel support will allow translation. As a result, after some time, the beam is going to become like this. Okay. Like this. Now, in the second case, if all the reactions are parallel to each other, so this is parallel to this is parallel to this. So there is no reaction which is not in line with these reactions. So we can see it is possible in case of 3 wheel loads and the truss is going to simply move. Okay. So this is again an unstable truss. So now we are talking about internal stability. The truss is internally stable if at each joint there is fixation and there is rigid body motion prevented. Okay. This is the internal stability. The simple trusses are always stable as they are built from a basic triangular unit with rigid extensions. Okay. And the third point is For the compound trusses, the stability depends on how simple trusses are connected. If connections are concurrent at a point in a figure, the truss may rotate or become unstable. Okay? Because here you see the point of concurrence is coming is this common point. So there is a large tendency for this inside truss to get rotated. Okay? So this is how we are going to check the internal stability of a truss. Now, when we are talking about complex trusses require analysis to determine stability, as visual inspection may not suffice. Okay. Stability can also be checked computationally by solving the 2J equilibrium equations. If inconsistent results appear, the truss is unstable. So what is the stability condition? Stability condition is B plus R should be equal to 2J. If this is the condition, I can check the stability or the determinacy of my beam. Okay. If B plus R is greater than 2J, the beam is extra stable or maybe internally unstable. But if B plus R is less than 2J, that means the number of bars are more compared to number of joints, and then there is tendency of beam to become externally unstable. So now in the next class, we are going to discuss the ways to determine the unknown member forces. Okay. So what we are saying here is that you are given a truss. Okay. Let us consider a simple truss which is having one pin support and one roller support. Okay. From your knowledge of engineering mechanics as well as mechanics of solids, you know that the support reactions are going to be, let's say the support names are A, B, and C. So there will be an AY, which is the vertical reaction, and there is AX, which is going to be the horizontal reaction. And here we are having CY. Okay. And of course, there are three member forces. So here FAB, the member force in the member AB, and FBC, which is the member force in the member BC, and FAC, the member force in the member AC, they are unknown. Okay. And secondly, you also don't know the values of AX, AY, and CY. These are also unknown to you. So your first task is to determine these unknown forces or reactions. How do you do it? It is something very simple which we have studied before in your engineering mechanics or mechanics of solids. We are simply going to isolate each joint and do the analysis of that joint. For example, if I talk about joint A here, it is having unknown AY, it is having unknown AX, it is having unknown FAC, and it is having unknown member force, which is FBA, sorry. So now your job is to find these. So you can simply apply the moment equilibrium equations and find out the support reactions first. How you can do that? So firstly, what you are going to do, you are going to do the summation of moments about A point as 0. Okay. Why this is going to be true? It is going to be true because my entire beam, my entire truss is in rotational equilibrium. And because of rotational equilibrium, my truss is not rotating. That means all the rotating moments which are acting on this truss should balance each other. And if they balance each other, their summation value is going to be 0. So if I do summation of moments about any point not just A, but even if I do the summation of moments about B or C, the summation of moments is going to be 0. Okay. But why I am doing summation of moments at A only as 0? Because immediately AX and AY are going to vanish. And what will remain is only CY. Mind you, I have not specified any force. So let's say this force is P and this is A, this is A. So if I do the summation of moments about point A as 0, we are going to get Cy into 2A is equal to P into A. Or the other way to write is Cy into 2A minus P into A equal to 0. So Cy comes out to be Pa upon 2A, which is P by 2. Okay. Now if Cy is P by 2, you can tell me what is the value of Ay, because I know that Ay plus Cy equal to P. That means Ay plus P by 2 equal to P. Therefore, Ay equal to P by 2. Alright. And also you can do the summation of forces in x direction is 0. So this is your summation Fy equal to 0 equation. And if you do summation Fx equal to 0, you are going to get Ax as 0. Okay. So this is how you are going to find the support reactions. Once you have determined the support reactions, you can find out the member forces also. Okay. How to do it? Basically, you are going to now take each joint and apply the known forces first, which is P by 2, and show the unknown forces with the help of arrows as FAB and FAC, and this angle is theta. Okay, for example. So now you can solve for summation Fx equal to 0 and summation Fy equal to 0 to get the two unknowns found. So you can write FAB sine theta plus P by 2 equal to 0 and FAC cos theta equal to 0. From here you can find the values of FAB and FAC, and this way you can determine the unknown forces in the truss. So thank you all for this lecture. In this lecture, we discussed the basics of trusses, and we also discussed in a preliminary way how to find the members, how to find the member forces. So in the next lecture, we are going to discuss this method in more detail. And by the way, the name of this method is method of joints. Thank you very much for this lecture.